Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. We're going to bring on our special guest that we've had before, astronomer Ken Croswell, author of a number of great books, including Planet Quest and one of my favorites, The Universe at Midnight. And being an astronomer, we're going to ask him all sorts of questions about, well, the eclipse, which happened a while ago. Also, speaking about the sun, solar flares. We dodged the bullet the other day, and the question is, how dangerous are solar flares if they hit the Earth? And Saturn. Saturn is in the news because the Cassini spacecraft was sent right into Saturn, and it makes an extraterrestrial collision. So once again, our special guest today is Ken Croswell, astronomer at Berkeley. Ken, glad you could be on Science Fantastic.
Glad to be here, Michio.
First question for you, the eclipse that happened a while ago, where were you when we had that historic eclipse that cut right across the U.S. of A.?
Well, I was southwest of St. Louis, and we had very good skies. We had a bit of cirrus. These are the white, thin, feathery clouds, and there were some cumulus to the east and to the west. But as the moon, cumulus clouds, I should say, are these puffy white clouds that look like cotton candy, and they can definitely ruin an eclipse if they pass in front of the sun. But as the moon passed in front of the sun, what happened was that the convective upwelling that causes cumulus clouds cut off, and the cumulus clouds completely dissipated. So we were left with just a few cirrus clouds through which we could easily see the sun. And so it was a very nice eclipse. We had 2.5 minutes of totality. I saw the diamond ring, which occurs both right before the eclipse and right after the eclipse. And right after the eclipse, I also saw, just for a brief second, the chromosphere, which is this layer of pink gas that's right above the sun's surface. I also saw the planet Venus, but nothing else, I'm afraid. The sky did not actually turn black. In fact, it didn't even turn all that dark blue. It was a darker blue than normal, but that surprised me a little bit. But probably my biggest impression was the crickets. They started chirping really loudly, actually well before the totality began, maybe 15, 20 minutes before, because they thought night was coming. On the other hand, there were a couple dogs near us, and the dogs didn't do anything strange at all. They just took it all in stride. Probably the biggest problem was that it was really hot and really muggy. Temperature was 92 degrees with a dew point of 76. Very uncomfortable weather. But the eclipse was really nice.
Well, as it turned out, I was also in the vicinity of St. Louis. I was speaking at Cape Girardeau and at the Southeast Missouri State University. And yeah, it was spectacular, the thing that you mentioned. However, the TV station that invited me down there had a rooster, and the rooster was supposed to crow when dawn emerged. However, the rooster did not oblige and did not crow when the eclipse was over. But it was spectacular. I, too, saw Venus. Some people said they saw Mars, the red planet. I didn't see Mars, but I definitely saw Venus. Now, also, the next eclipse, I think, will take place in 2024, right?
That's right, and that's rather unusual because the last time we had an eclipse like this was actually 99 years earlier. So it is rather peculiar to have yet another total solar eclipse. And this is a total solar eclipse, by the way. A partial solar eclipse is really no big deal. But this is another total solar eclipse when the moon completely blocks the sun. And that will cross the United States on April 8th, 2024, so just 7 years from now. And some places that it will cross will be Dallas, Texas, Little Rock, just south of St. Louis again, Indianapolis, Cleveland, Montreal, and Rochester, Buffalo, and the northern part of New England. So if you've always wanted to travel to one of those places, or if you have a long-lost friend or relative in one of those places, well, you might arrange to take a vacation around April 8th, 2024, and then the eclipse will be the icing on the cake.
Well, I live in New York City, but I guess the eclipse will bypass New York, right?
You'll only see a partial solar eclipse from New York City. You'd have to head to the north or the northwest. So, for example, Rochester and Buffalo would both be getting the complete totality. Cleveland as well, and the northern parts of New England. So if any of those places sound appealing, those would be good. Of course, on the big day, as we all learned on this past big day, August 21st, what really counts is the weather, and you can't predict that in advance. But the weather in most places in the U.S. in April is usually pretty pleasant, unlike in August, and so I suspect at least you won't have to be suffering the heat and humidity that many of us had to put up with for the past solar eclipse.
And I understand that somewhere on the planet Earth there is an eclipse, every few months, every few years, right?
Yeah, they are, but it's a very small area of the Earth that experiences a total solar eclipse. That's why any one place, it's very rare, unlike with partial solar eclipses, and also unlike with total lunar eclipses. Total lunar eclipses are quite nice to observe too, but but basically half the Earth can see a total lunar eclipse when one occurs. Total solar eclipses, though, are things that if you're really fanatical about these things, that you really have to travel to. And there are, in fact, people who spend thousands of dollars every year to go to every single total solar eclipse. For me, I've decided I'm going to conserve my money and wait for the eclipses to come to me. So the one that I saw in August was actually my very first total solar eclipse. I don't know about you, whether it was also your first or whether you had seen them before.
Yeah, no, that was my first. Now, the sun is 400 times bigger than the moon, but it's also 400 times farther away, and the two 400s cancel each other exactly. Now, as I understand, in our solar system, if you look at the various planets of the solar system, nowhere do you have this precise cancellation other than on the planet Earth. And perhaps in this sector of the galaxy, if you think about it, we don't know for sure, of course, but isn't it possible that perhaps in this sector of the galaxy that there are no total eclipses other than on the planet Earth? What are your thoughts?
Well, it's certainly true in the solar system, and yet it's only a temporary thing because the moon is slowly moving away from the Earth. So we just happen to live at a time when this exact cancellation occurs. If we lived, say, 1 billion years earlier, the moon would be a lot bigger than the sun as viewed from Earth. And if we lived 1 billion years from now, we would never see total solar eclipses. So we live at just the right point in history when the moon is the right distance from the Earth to completely cancel the sun without overdoing it. As to whether there are other planets and other moons in our galaxy that have the same arrangement, given the enormous number of planets that must exist and the number of moons, surely someplace, somewhere, there is a similar combination, but probably it's a planet that has no life. So we are very lucky to be here on Earth at this very time to be able to see total solar eclipses like this.
Now, some people think that the sun is life-giving, it's benign, harmless, and where would we be without sunlight after all? However, recently there was a gigantic solar flare that whizzed by the planet Earth, and if it had hit, all hell would have broken loose. So tell us a little bit about these solar flares and these coronal mass discharges.
Yeah, they can be quite damaging if they're heading right straight toward Earth. And in fact, the most colossal such event occurred back in 1859, the Carrington event. Had that hit today, it would have quite possibly wiped out a lot of our electrical grid and a lot of the modern communications that we take for granted nowadays. So we definitely have to keep monitoring the sun. Now, the good news is that long ago, the sun was actually far more active than it is today because the sun spun faster. And it's the rotation of the sun that stirs up the sun and stirs up its magnetic field, intensifies the magnetic field. And we know this because when we look at young solar-type stars, such as, for example, stars in the beautiful Pleiades star cluster, we see that the solar-type stars are rotating faster than the sun, and they have more magnetic activity and more flares. And so it's good that we live around a middle-aged star rather than around a young star. The sun is 4.6 billion years old, so it's mostly settled down, but every now and then it does throw off a sign of its past use. I wonder to what extent past solar flares, and I'm talking billions of years ago when the sun was much more active, may have actually helped life on Earth by causing genetic mutations that led to evolution, changes in evolution of creatures on Earth. So who knows? Maybe the sun, in addition, of course, to giving us light and warmth, maybe it also sped up the advancement of life here on Earth.
Now, I understand that the American Physical Society and the American Association for the Advancement of Science, scientists have estimated that if another Carrington event were to take place, property damage would be on the order of $2 trillion. That trillion with a T, not a B. So tell us a little bit about what could happen to the space station, astronauts, our satellites, and even power stations on the Earth. If another big one were to hit, what would happen?
Well, if it were something like what happened in 1859 with the Carrington event, I mean, to be honest, nobody really knows for sure because, thankfully, it's not happened in the modern era. But the astronauts would surely be exposed. The astronauts aboard the space station would be exposed to an enormous amount of radiation that might lead to a greater instance of cancer in the future. It might well knock out our GPS systems and just cause a lot of havoc. But really, we aren't going to know what's going to happen until it actually does happen. I mean, we saw the predictions, for example, for Hurricane Irma didn't really quite live up to the doom and gloom scenario that had been made in advance. So you never really know. When you're talking about the future, you never really know what exactly is going to happen. But I just hope there's not. I would rather not live through another Carrington event. Let's just put it that way.
And Quebec was hit by a gigantic solar flare and caused power stations on the Earth, not in outer space, power stations on the Earth to black out. And that was just a glancing blow. So think about what happened if the entire northern hemisphere were to hit by a gigantic solar flare. So do you think, therefore, that we should begin to think about redundancies, maybe shielding some of our satellites, maybe taking extra precautions? These physicists recommended that to the United States Congress, but the Congress simply giggled, laughed, and dismissed it. But what are your thoughts?
Well, I think it definitely makes sense to spend a little bit of money to insure against the worst. So, without question, because the worst could be very catastrophic. So, yes, it definitely makes sense to employ some redundancies, as you say, to strengthen the electrical grid and all the other things that might be damaged in a really big solar flare. Because it is going to happen sooner or later. It may not happen in our lifetime, but sooner or later it will happen.
And also, apparently, these solar flares leave an imprint in the ice. The chemical composition slightly changes, and you can measure that by going into the ice in Greenland, digging into the ice, and finding out when the last Carrington event took place. Luckily, the cycle time between these events is more than 100 years, perhaps a few centuries. But hey, the last one was 150 years ago, right? So isn't it prudent, therefore, to take this seriously? What are your thoughts?
Yes. I mean, without question, it's going to happen sooner or later. It may not happen in the before the next election cycle for the politicians, but it could happen during our lifetimes. And so it makes sense to take precautions. And, of course, it's not just the United States. I mean, the whole world should take precautions against this because you never know where it's going to exactly hit.
Okay. Now, moving on, let's talk about Saturn. Years ago, we sent a space probe called the Cassini orbiting around Saturn, gave us gorgeous, gorgeous photographs of the rings of Saturn, answered a lot of mysteries about that gas giant. But now it's nearing the end of its life, and recently it plowed into Saturn itself. So tell us a little bit about the Cassini space probe.
Well, the Cassini mission was a great success. It was the very first spacecraft to go into orbit around what is arguably the most beautiful planet in the solar system. And this planet has, of course, the beautiful rings and a whole system of moons, 62 moons that we know of. And Cassini, because it was in orbit, it was able to study the planet, the rings, and the moons for a prolonged...
Okay, Ken, we have to take another short commercial break. But after that, we're going to continue a discussion of what happens when we plow a space probe right into Saturn. And then we're going to move on, talking about Uranus and the universe. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is astronomer Ken Croswell of Berkeley.
So, for example, we had Pioneer 11 and Voyager 1, Voyager 2. They all flew past the planet, gave us intriguing glimpses of the planet, taught us a lot about planet Saturn, its rings, and its moons. But the nice thing about Cassini, which was launched in 1997 and arrived in 2004, it went into orbit around the planet. So we didn't get just a brief glimpse of the planet. We got a prolonged view. And as to why we have destroyed the spacecraft by sending it into Saturn, we didn't want it to crash into one. It was running low on fuel. And we didn't want it to accidentally crash into one of the moons of Saturn that might have some form of life on it, such as Titan, which is the largest moon of Saturn, or Enceladus. And because obviously if we contaminated one of those two moons with Earth life, then we would never be able to determine whether those satellites actually had native life on them if we were to explore those moons further in the future. So that's why we have destroyed the spacecraft. But it's after a very long mission. As I say, the spacecraft was launched 20 years ago, October 15th, 1997, and it died September 15th, 2017. So it almost lived 20 years, and it's been a fantastic mission. It's discovered 7 of the 62 known moons of Saturn. It's given us intriguing views of those moons. We now know that there are geysers of water shooting into space from the moon Enceladus. We landed a spacecraft on Titan, and thus saw the surface of Titan, which is shrouded in an orange haze. So it's taught us so much about the planet, the moons, and the rings. It's been a very successful mission.
And speaking about the rings of Saturn, every kid wants to know, where do those rings come from? I mean, after all, the gas giants have rings, but they're very thin and tiny compared to the magnificent rings of Saturn. Does anyone know, or is it just a theory?
Well, no one knows for sure, but one theory is that maybe long ago, an asteroid or a comet just passed too close to Saturn, or maybe one of the moons of Saturn strayed too close, and Saturn's gravity tore that object apart and split it into trillions of particles that now orbit around Saturn in a single plane. What we do know is what the rings of Saturn are made of. They're made up almost entirely of water ice. So they're bits of water ice. Some of them are as small as pebbles. Others of them are as big as horses and houses. So it's basically trillions of particles of water ice going around the planet Saturn. And it's a very clean system. There's very little else in those rings besides water ice. Very different from the planet Uranus, which also has rings, but those rings are dark. Saturn's rings are bright, they're very beautiful, and we've known about them for centuries. And it's what makes Saturn one of the most beautiful planets in the solar system. And who knows, maybe one of the most beautiful planets in the entire galaxy.
Our special guest today is astronomer Ken Croswell. And we were talking about Saturn, the fact that one of our space probes, Cassini, at the end of its mission, plunged into Saturn like the Galileo mission years ago plunged into Jupiter. Now, some people think that one of the moons of Saturn, called Enceladus, may have oceans of liquid water and, who knows, perhaps even life. So how can it be? How can it be that a moon so far from the sun, which is basically frozen, have liquid water oceans that may even have life in them? What are your thoughts?
Well, it's the magic of gravity. Enceladus is simply one of 62 moons, and tugs from the other moons of Saturn actually squeeze it a little and stretch it and heat it up. So what would otherwise be solid ice actually gets turned into liquid water. And, of course, since we human beings are made in large part of liquid water, and so is all other life here on Earth, whenever we see liquid water in the universe, we start to wonder, hey, could there be life there? So it's basically through gravity that Enceladus, even though, as you point out, very far from the sun, and by all rights ought to be frozen solid, actually stays somewhat liquid. And it almost unquestionably does have an ocean of liquid water beneath its icy surface, and it shoots that water into space. And in fact, one of the rings of Saturn, the E ring, is made of particles spewed into space by Enceladus.
Now, Jupiter has a moon called Europa. It also has a liquid water ocean.
Yes.
And NASA originally wanted to send a submarine, believe it or not, to probe Europa, but that was delayed or even canceled. But I understand that NASA still has hopes of sending something to Europa. So what might we do, given the fact that there is some funding to send at least one probe to one of the moons of Jupiter?
Well, certainly Europa is a very interesting moon. Actually, many of the moons of the solar system are very interesting. And Europa could have some form of life in that ocean beneath the icy crust. The problem is, how do you sample that ocean? How do you get into that ocean? And that's not so easy. I mean, drilling through miles and miles of icy crust to reach that ocean is something we haven't even done here on Earth. So I don't know how we would actually get into that ocean. The nice thing about Enceladus, the moon that goes around Saturn, is it's actually spewing its ocean into space. And so a spacecraft could conceivably fly through that material that Enceladus is giving off and sample that material. So Enceladus actually might be the easier moon to sample its ocean and to see whether there is some, let's say, microbial life in that ocean, simply because we can more easily sample the ocean than we can with Europa. But certainly if somehow we could get into that ocean and explore that ocean, well, it would be a fascinating thing on Europa.
Okay, moving on, we have Uranus, a planet that is beyond Jupiter and Saturn. And recently there's been some discussion about how stable the moons are that orbit around Uranus, given the fact there's so many of them. So could you elaborate about the stability of our solar system?
Well, it looks like those moons are going to be colliding with one another based on some brand new measurements of the density and the mass of one of them. The planet Uranus has 27 moons that we know of. 9 of those 27 moons are very tightly packed. They all lie within about 12, their orbits all lie within about 12,000 miles of one another. That's a bit less than twice the diameter of the Earth. And so if they're sufficiently dense and massive, the gravity of one will pull on the other moons, and causing one to swerve into the wrong lane and collide. And based on this new measurement, we do find that one of the moons, called Cressida, has a sufficiently high density so that if the other moons are also similarly dense, and they probably are, a number of these moons are going to be colliding in just the next million years or so. And that's, a million years, that's with an M, that's not very long compared to the age of the solar system, which is 4.5 billion years old. So Cressida, it looks like it's going to collide with a moon called Desdemona, which lies very close to it in just the next million years. And there's a couple other moons that are likely to collide as well, called Cupid and Belinda. So what this means is that surely these moons have probably not existed for the lifetime of the solar system. So, normally we look at the solar system and we think it's always basically been there for the last 4.5 billion years. But what this work is telling us is that some of the moons are much more recent.
Okay, well, we have to take another short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku, and we're talking to astronomer Ken Croswell, author of the book Alchemy of the Heavens. So stay tuned as we explore the universe with Dr. Ken Croswell. Michio Kaku. Our special guest today is astronomer Ken Croswell of Berkeley, author of the book Alchemy of the Heavens. And speaking about stars, many science fiction buffs want to know what is the closest star to our sun, given the fact that one day perhaps our descendants will send a space probe to that nearest star. Well, it's the Centauri star system, but how many stars are there in the Centauri star system?
Well, I hope it's we who send that spacecraft, not our descendants, but there are actually 3 stars in the Alpha Centauri star system. The two brightest are called Alpha Centauri A and B. We've known about them for centuries. They go around each other every 80 years. One is yellow, the other is orange. And then about 100 years ago, an astronomer in South Africa discovered a much fainter star that tags along with them called Proxima Centauri. The reason we named it Proxima is because it's slightly closer to us than are the other two. It's got a distance of 4.24 light years versus 4.37 for the brighter stars. And there's always been a little bit of a debate as to whether Proxima Centauri is really gravitationally bound to Alpha Centauri A and B, simply because it's so far away from those two other stars. It's 13,000 times farther than the Earth is from the Sun. And now we have new measurements that indicate that, yes, it actually is gravitationally bound to the other two. Astronomers measured the precise velocity of Proxima Centauri through space and compared that with the precise velocity of Alpha Centauri A and B, and concluded that they are almost on very, very similar paths, so similar that the one star does revolve around the other two. And it takes about 500,000 years for Proxima Centauri to revolve once around Alpha Centauri A and B. Now, for comparison, the Earth, of course, takes just 1 year to go around the Sun. Even distant Pluto, my good friend, the planet Pluto, takes 248 years. But Proxima Centauri is so far from its peers, Alpha Centauri A and B, that it takes about 500,000 years to revolve just once.
Now, in the movie Star Wars, there was a controversial scene where Luke Skywalker looks in the sky and sees two stars, not one sun, but two suns. And many astronomers scoffed at that. But isn't it true that we've seen four star systems? I understand that there could be a system with two double stars rotating around each other. But what are your thoughts?
Yes, yes, indeed. There's a very famous star called Castor in the constellation Gemini. You can see it with the unaided eye, and it consists of 6 stars, although we don't know of any planets in that system. The first good case of a planet going around a double star is called Kepler-16, and this is a star system that consists of an orange star and a red star, and there's a planet that goes around that star. And so if there were a Luke Skywalker on that planet, yes, he would see a double sunrise and a double sunset. So it's not just science fiction anymore. There really are planets going around double stars. You don't have to have a single star in order to have planets, although, of course, the Earth is the sun is a single star with its planets. But there are plenty of double stars that have planets, too.
So you're saying that up to, 6? You can have up to 6 stars gravitationally bound, rotating around each other? Is that what you're saying?
Well, we know of up to 6 among the bright, famous stars, and I wouldn't be surprised if we could have even more than that. So, gravity doesn't discriminate. I mean, and of course, we have star clusters in which you have hundreds or thousands of stars that are gravitationally bound to one another. Now, where you draw the line between a star system like Castor or like Alpha Centauri and an actual star cluster, I don't know. That's perhaps given what a mess astronomers made of trying to define a planet, maybe we should not try to define the difference. But I can tell you that among the bright stars, Castor definitely have 6 stars. 4 of them are bright and white, and 2 of them are faint and red. It's a very interesting star system. Again, we don't know of any planets there, but I wouldn't be surprised if there might be some planets there. We definitely know that planets can exist around multiple stars, just as planets, of course, do exist around single stars like the Sun.
Amazing. And also looking at the heavens, it was recently announced that yet another extrasolar planetary system was discovered with 4 Earth-like planets, only 12 light years from the Earth. So give us a rundown as to what some of the latest discoveries are about extrasolar planets.
Well, probably the most exciting discovery of the past 2 years is a planet going around the star that you mentioned a couple minutes ago, and that's Proxima Centauri, the very closest star to the Earth, the very closest star to the Sun, very closest individual star to the Sun. And that planet appears to be in the habitable zone of Proxima Centauri. So it could conceivably have liquid water and some form of life. And so this has certainly spurred ideas for how we can send a spacecraft, an unmanned spacecraft, to investigate the Alpha Centauri system, and in particular that planet, the planet going around Proxima Centauri.
Now, I understand that some other extrasolar planets look very much like the Earth, except they go around a red dwarf star, which apparently could be quite active and have a lot of solar flares, which could wipe out life on that planet. So could you elaborate what happens when we discover an Earth-like planet going around not like our sun, but a star called a red dwarf?
Yes, we were talking earlier about solar flares, and red dwarfs, many of them have very active solar flares. So we do worry about what the consequences would be if you have a life-bearing planet going around a red dwarf. Okay,
well, unfortunately, our time is up. Once again, you've been listening to Science Fantastic with Professor Michio Kaku. Our special guest today was astronomer Ken Croswell. And get a copy of his book,